Well, alright folks, it's been a long time since I made a video, but here's another new one. I've got a problem here that we had from homework. It's just simplifying some trigonometric functions, some expressions I should say. With these problems, try not to get too frustrated with yourself. It's really easy to go down the wrong path with these. It's hard to know necessarily how to rearrange the terms so that it works out. I've definitely worked out a bunch of these where I just went down the wrong road and I ended up with a bunch of a mess. As an example of that, I was actually working on one of our own quizzes that we did in class, and I'll try not to be too messy here, but wow, that looks like a mess, doesn't it? So I was working on a problem and then I got stuck. I eventually went back and redid it and I was able to do it the right way, but the reason that happened is I didn't know exactly right off the bat how to rearrange terms. And it wasn't this problem, but it could easily be this problem. It's hard to know right away which path to take. So I'm going to work out this problem. It was from the homework, and I'm gonna cheat a little bit. I got it worked out over on the side here, but basically I'll try to walk through my thinking when I do this. So when I'm working with this problem, I see a secant squared theta, cosecant theta on top, secant squared theta plus cosecant squared theta on the bottom. So resist the urge to just cancel these out. That can't happen because we have this plus sign here. If it was a multiplication, you could cross some things out. All right, so let me work right across. This is equivalent to secant squared theta is just 1 over cosine squared theta, right? Because secant is 1 over cosine. And then that's being multiplied times, so I'm going to use a little dot there. 1 over sine theta. And that's going to be my numerator. So all I did is rearrange those. You could have easily rewritten secant squared theta as, what is that, cotangent, let me look back at my notes. That's 1 plus cotangent squared. No, I'm sorry, tangent squared plus 1 is secant squared theta. So you could have rewritten that as a Pythagorean identity. That won't really get you in the right direction there. So, all right, now let's work with the bottom here. So I've got secant squared theta plus cosecant squared theta. I'm going to rewrite those in the same way, so I'm going to just put 1 over cosine squared theta plus 1 over sine squared theta. And when I did that initially, I was like, all right, great, but now what? I'm kind of stuck again, right? So I'm going to come down here, I'm going to write another equal sign. So this is going to be equivalent down here. All right, we would come all the way back down. I would like to work with my bottom piece here. So I see some cosine squared thetas and some sine squared thetas. And I know when I add them together, if I add them together just by themselves, it equals 1. But I only have them in the denominator now. So for this piece right here, I'd like to, in order to add them, this is missing a sine squared, this is missing a cosine squared. So I'm going to multiply the bottom. So my numerator is the same, cosine squared theta times 1 over sine theta. So I just rewrote that. And then I need sine squared theta over sine squared theta in my denominator. So we've got a fraction and a fraction. And over here, I need a cosine squared theta over cosine squared theta times 1 over sine squared theta. So it's a lot, right? So all I did, this is 1, and this is 1, and this was that, and this was that. And all I'm trying to do is get a denominator here so I can add, right? And I can add this to this because now the denominators will be the same. So my denominator will be cosine squared theta, sine squared theta. That's why I did all that. And then my numerator will be cosine squared theta plus sine squared theta. I actually should have written sine squared theta plus cosine squared theta, just so that you would see it's the order. I flapped those, but it doesn't matter. This is going to end up being 1. And my numerator was still the same. 1 over cosine squared theta times 1 over sine theta. All right. So I'm trying to keep my work organized here. As you can see, I'm taking up a lot of paper. It's going to be a lot of steps. So let's see what happens here. So this is going to be 1. Cosine squared theta plus sine squared theta is 1. So let's see. My numerator is still 1 over cosine squared theta times 1 over sine theta. My denominator is now 1 over cosine squared theta sine squared theta. And again, that is because of the Pythagorean identity. Now, I've taught you how to work with this before. What I do is I multiply times the reciprocal. So I'm going to multiply the numerator and the denominator. Right, this same thing on top and bottom so that it's this same equation. I'm going to have cosine squared theta and sine squared theta. I'm getting kind of jumbled here, over 1. So this is cosine squared theta sine squared theta over 1, right? And let's see, so these are going to cancel. That's why I did that. Now what's going to cancel here? Because this is all one thing. Remember, this is multiplied across, so this is really just one fraction here. This is just multiplication, so the denominator of this is almost just a really big fraction. Cosine squared theta times sine theta. So the cosine squared thetas are going to cancel here and here, and the sine squared theta and the sine theta, the squared part will cancel. The squared part will cancel with this, and I'll be left with just sine theta. That's all that'll be left over. So the key is keeping your numerators and denominators intact, making sure you're not just randomly canceling things. When you see addition and subtraction, you can't just cancel things as easily, but when it's all multiplication, that's a really good thing. So that's how you do that one. I'm going to pause my video and then I'll start back up again, and I'll do one more example from the homework. All right, so here's my other example, if my thing would focus here. All right, sweet. I've got two fractions. I need to add them together. But the problem is I don't have the same denominator here, right? Over here I've got 1 plus sine theta, over here I've got cosine theta in the denominators. In order to add fractions, I need the same denominator. So I'm going to multiply this one times cosine over cosine, because this one has a denominator of cosine. I'm going to multiply this one times 1 plus sine theta over 1 plus sine theta. All right, and I'm going to do that all at once, and let's see if you can follow. So my new denominator will be cosine theta times 1 plus sine theta. So I'm skipping a step here. I'm hoping you can follow. So when I multiply this one times cosine theta over cosine theta, my numerator will be cosine squared theta. My denominator would be that, right? And then my numerator over on this part will be, I'll have another factor of 1 plus sine theta, because I will have multiplied this one times 1 plus sine theta over 1 plus sine theta, as I just mentioned before. So this will be 1 plus sine theta squared, right? And I would have had these as separate fractions, but when I added them, it would look like this, okay? So that's the first step. And again, everyone should get that first step just to add the fractions. Now, where should I go from here? Well, I need to be able to see 1 plus sine theta, that whole quantity squared, as something. I'd really like to look at a sine squared theta because I see a cosine squared theta, and I know sine squared theta plus cosine squared theta is 1. So I'd like to multiply this out. This is 1 plus sine theta squared. So that's like having, and I'm going to do a little side example here. So this is a little side example here. Keep in mind, when you have 1 plus x, and I'm using x in place of the sine, if you have this squared, it's not just 1 plus x squared. It's actually this, 1 plus x times 1 plus x, okay? And when you multiply that out, you get 1 plus 2x plus x squared. So resist the urge to just write 1 plus x squared. It's actually this. And the same thing's going to happen there. So here I used an x. This is just a sine theta, all right? So I'm going to come down here, and I'm going to rewrite this. I'm going to have cosine squared theta plus 1 plus 2 sine theta, and that's that part of the equation, right? This part, it's equivalent, plus sine squared theta. Okay, so that's my entire numerator now. And then on the denominator, I've got the same thing that I had before. All right, so that's super helpful because I have a cosine squared theta and a sine squared theta, and they're being added together. Those combine to give you a 1. So that's 1 plus the rest of the stuff. There's the other 1 plus 2 sine theta. All over the same thing I had before. Oops, forgot a parenthesis. Sorry about that. I'm going to come down here. This comes down over here. So 1 plus 1 is 2 last time I checked. All right. Then I've got cosine theta Okay, so what can I do from here? Can I just cancel out the sine theta? And this, no, you cannot. There's this plus sign here, it's messing things up. What I can do is recognize that there's a 2 here and there's a 2 here. So I'm going to factor out a 2, and I'm going to be left with 1 plus sine theta. So the common question at this point is, where did the 2 go from here? I factored it out. 2 times 1 is this. 2 times sine theta is this. So I just factored out the 2, okay? And the reason I did this is because, look, 1 plus sine theta, I'm going to have a 1 plus sine theta on the bottom. 1 plus sine theta. So now I've got a factor of 1 plus sine theta and a factor of 1 plus sine theta. Those can now cancel. This whole factor cancels. And I'm left with 2 over cosine theta. And if I have a cosine theta in the denominator, that's really the same as 2 secant theta, which is your answer. So all of that to get 2 secant theta. Again, it's tough to see the path right away. Try to take your time, see where it takes you, and if you need to start over, start over. Write clearly, make sure your fractions are really clear, and then use your notes to figure out if it's cosine squared plus sine squared, and keep in mind there's a whole lot of them. All right? Good luck.